So you should already know how to solve polynomial equations. Like, for example, this is a polynomial inequality where you have a polynomial and polynomial on the right side. Here I simplified it down. I already made the right side 0. But if this was like an equal sign, you should know how to solve this. And if you had terms like 3 or 4x plus 2 on this side, then you should know you should move them over first to get this right side equal to 0 and then solve it. But we're going to focus on if it's an inequality instead of an equal sign. And it's still kind of the same process. First, you need to move all your terms to the left side or just one side, and I've already done that. And then you need to factor it, factor the polynomial. This one's pretty easy because it's a quadratic. It's going to be x minus 3 times x minus 4. And find your solutions. So x equals 3 or 4. And these are not your answers, because when it's an inequality, your answer is usually going to be an interval. Because if you think about it, on like a graph, like let's say it's like this, and you want to find when the equation is less than 0. It's not going to be just like one point like this or this, but it's going to be this whole area in between. So it's going to be a region. And if it's like you want greater than 0, it's going to be this region and this region. So sometimes you might have 2. But anyways, draw a sign diagram with points at your solutions, 3 and 4, and then test different points here, here, and here to get your signs. So let's test x equals 0, which is going to be negative 3 times negative 4. That is positive. So this region is positive. Let's test 3.5 for this in-between part. So it's going to be 0.5 times negative 0.5, and that's negative. So this will be negative. Let's test 5 for this part. That's going to be 2 times 1, which is positive. So we have all our signs from negative infinity to 3. This equation is positive. From 3 to 4, it's negative. From 4 to infinity is positive. But the inequality asked for when the equation is less than 0, meaning when it's negative. So it's just going to be this region here in between 3 and 4. So you can write 3 is less than x, which is less than 4. That's your final answer. And if you had it instead like this is less than or equal to 0, then you would also include your solutions in your inequality. So you would just do this. And sometimes, like I said, your solution is usually going to be an inequality like this, but sometimes it will be just like a single point. For example, this inequality right here, x minus 3 squared is less than or equal to 0. Let's solve this first. You find the solutions to x minus 3, which is x equals 3. Draw your sign diagram. Let's try 0. Negative 3 squared is positive. Let's try 4. 1 squared is positive as well. So you notice that both these regions from negative infinity to 3 is positive, and from 3 to infinity is also positive. So neither of these, like before 3 or after 3, would work. Instead, it's just this single point 3. So x equals 3, because that's the only point where it's less than or equal to 0. And now let's do a practice problem. So if you think you can do this one, then pause the video and try it. This problem says to solve the inequality x cubed plus 2x squared is greater than x plus 2. And this is a cubic function, so it's going to be a little hard to factorize. You might need to use some tricks. But you can notice that this left side is just the right side times x squared. So we can write this as x squared times x plus 2 is greater than x plus 2. And then, again, move these terms to one side so you get 0 on the right side. So x squared times x plus 2 minus x plus 2 is greater than 0. And we can factor out an x plus 2 out of this, so x squared minus 1, and then this is just difference of squares, so this becomes x plus 2 times x plus 1 times x minus 1 is greater than 0. Now we fully factorize it, and we need to find our solutions to the right side or the left side. So x equals -2, -1, and 1. Now we draw a sign diagram with points at our solutions, -2, -1, and 1, and try every single region. So -3, that will be -1 times -2 times -4, and that's negative. So before -2, it's negative. Let's try -1.5 for this region. So that will be 0.5, -0.5, and -2.5. And that is positive. So this region is positive. And usually, when you have a sign diagram, these signs are just going to be alternating between each region. So like this will be probably negative, positive, but it's just better to check just in case. And let's try 0 for this region, which is 2 times 1 times -1, which is negative. And let's try 2 for past 1, which is 4 times 3 times 1, and that is also positive. So we figured out all our signs for the regions, and like I said, you can tell that it's just alternating between negative and positive. So if you're like running out of time, you can just write negative, positive, and the only time it's going to not be that pattern is when you have a repeating solution. So yeah, but I think it's better to just check it if you have time. And anyways, this question is asking for when this equation is greater than 0, so when it's positive. So the regions are going to be -2 is less than x is less than -1, and or you can write or x is greater than 1. And that's your solution to this problem. So everything that I explained in this video and all the problems that I went through should give you everything you need to know about solving polynomial inequalities. If you learned something from this video, then please consider liking and subscribing.